Can't believe it's not CUDA. Let me set the stage for you. One of the largest, smartest tech companies in the world has an absolutely insurmountable lead in artificial intelligence. I mean, they've essentially got an unlimited budget and a license to print all the money that they could ever want, even if that's not enough. Their products are good, and you almost universally can't actually buy them. Even before their last generation products ever enter availability, they're already hyping the next generation products. And the foundries making next generation products are already going full tilt. Competitors, what hope do they have against that? It's a David versus Goliath situation, right? We need a small thermal exhaust port 2 meters wide to free ourselves from the death grip on the AI ecosystem, right? Who do you think I'm talking about? Nvidia? No. Google. Hello? Remember TensorFlow? Well, okay, TensorFlow is still a thing. It's still a big thing, and a lot of the math and libraries are still a big thing. But more specifically, TensorFlow-specific hardware. Although Google's TensorFlow YouTube channel is looking pretty dead these days. It's not looking great. I mean, not a lot of interest around people Googling TensorFlow, I guess. In the beginning, you could watch some old videos from Google on TensorFlow and TPUs, and their attitude was basically, yeah, you can run this on GPUs, but really, you want to run it in the cloud on a TPU because it's just better in every way. And a lot of Googlers seemed to have basically written off GPUs for everything except teaching yourself about the wonders of TensorFlow and tensor processing units. And you can see that in a lot of their coverage from 2015 through 2018. I mean, by 2016, Google was already demonstrating third-generation water-cooled TensorFlow TPU hardware, which is pushing something like 100x the speed efficiency of, the contemporary GPUs at the time. And yet here we are in 2023. Look around. No one noticed that for the 5th generation of TPU, which was actually due in June of 2023, that we barely heard a peep from Google about it. Where's my 5th gen TPU, Google? Where's it at? I need it. 5th gen was something Google was still pretty excited about, even as recently as April of 2023. And for what Google uses them for, at V4 TPU was between 1 and 4 times faster at half to 2/3 the power of Nvidia's A100. And so Google had expected their V5 to compare favorably to Nvidia's H100 that they just launched. Now, Google was able to productize their tensor processing units. I've got one here on this tiny M.2. This is a Coral.ai accelerator that can do people and object finding and security camera footage, for example. It is powerful beyond my expectations. This tiny little M.2 uses less than 15 watts, and it can analyze a scary number of 4K camera video streams at once. It really is breathtaking, and you can do this yourself. It's totally democratized. No cloud, but you know what? The part of it that was not breathtaking was the wait for it to get here. It took over a year from the time that I ordered it to the time that it made it here. Google had nearly a decade lead in doing things with AI and machine learning, but from a business standpoint, all the stuff that fits under the AI umbrella is what has catapulted Nvidia to $1 trillion company. So how did Nvidia win and Google lose? With AI, the future hasn't actually even been written yet, and the future can go in non-obvious ways, is my point. Don't believe me? That's exactly what Clement DeLange was saying to a room full of us at the AMD data center event. He said he doesn't know what the future is going to be like. Maybe AMD's VRAM is going to be an advantage. Maybe AMD's hardware process is going to be an advantage. Maybe NVIDIA is going to be. He doesn't know what the future is going to be. I don't know what the future is going to be. It's probably more bizarre than anything we can imagine. But I can tell you that even NVIDIA knows that H100s going for over $40,000 each on eBay is ultimately no good for NVIDIA. That kind of thing is just going to speed the adoption of something that's not $40,000 for that level of performance. And NVIDIA is on top now because they put together a far more developer-friendly ecosystem, and the accessibility was way higher versus TensorFlow in the early days of AI. NVIDIA's focus on accessibility and ease of use and taking care of students and educators, really, it's paid off. CUDA was nowhere near as open as TensorFlow, it still isn't, and yet NVIDIA is $750 billion up on their market cap from all the way back then. And now, just a few short years later, AMD's ROCm is in a similar position as NVIDIA was with TensorFlow. ROCm, however, is more open even than TensorFlow, which ultimately benefits everybody. And AMD's hardware is, probably their hardware process, is ahead of the curve, at least in my opinion. And I'm not the only one that thinks so. So today, in 2023, AMD is already in a much better position than Nvidia was when the first and second generation TPUs from Google had launched. And everyone was super excited for AI then. AMD is more competitive than most people realize and are only just really starting to wake up to that possibility. I mean, I really wouldn't bet against Lisa Su. If it wasn't obvious from all the top 500 supercomputers based on AMD products that AMD counts as wins, come with me into the trenches and let me show you the state of ROCm in 2023. I literally cannot believe how far ROCm has come since last year even. It's kind of mind-blowing. Here's our Supermicro AS-2114GT-DNR. It's 2 servers each with 3 Instinct MI210 GPUs. An MI210 is about half of an MI250. Check out our other videos on this system and the teardown that we did with Gamers Nexus. It really is super interesting. For this system, I've already got it set up and running with ROCm 5.5 and PyTorch, and this is based on the nightly. For our AI demo, we're going to be using Automatic 1111. Now, if you're not in the know, Automatic 1111 not only doesn't support AMD GPUs at all, they're just a wee bit hostile on the GitHub issue tracker if you come asking for AMD GPU support. They don't have enough bandwidth to support all the implementations, basically anything not CUDA. Okay, I mean, I guess that's fair. But it actually works fine anyway, though. I mean, technically, Automatic 1111 is just a web GUI front end for Stable Diffusion. It doesn't even really technically support multiple GPUs, although you can kind of hack that in there by running stuff in parallel on 2 different GPUs. I've downloaded a model from Hugging Face, and I'm running it with this prompt. We're going to generate 32 images, 16 on each of 2 MI210s on our AMD system, and then just a single thing running with our H100s. And by way of a direct apples-to-apples comparison in the output, this instance of Automatic 1111 is connected to our comparison system. But it's really a similar config. We're running a single Nvidia A100 GPU, which has 80 gigabytes of VRAM, and it's running at the full 300 watts. And to be sure, the A100 is a higher class of GPU than the MI210, but this Supermicro system with its multiple MI210s is the only Instinct hardware that I have available, and I only enabled 2 of the MI210s for this demo. I mean, the A100 is faster, more power efficient, but more than a few people have noticed just how much the gap has narrowed between these cards since the Instincts launched in 2021. And this is basically a direct like-for-like demonstration, with Danny DeVito, of course. Now, I've downloaded a model from Hugging Face to both of them that I've called I Can't Believe It's Not Photography.SafeTensors, and that's set up. Literally, I just copied the file from one system to the other system. We're going to generate 32 images in total. We've got 16 images being generated on each of 2 MI210s on the left system, and on the right system, we've got our setup for our single A100. Our single A100 is 80 gigabytes. Each of our MI210s have 64 gigabytes of VRAM. It's not apples to apples, but this is literally the only Instinct system that I have. I mean, 2 MI210s is very close to an MI250. I mean, an MI250 is a dual chip design, and the MI210s are a single chip, but the MI210s have a higher power budget. The power budget on the MI250 is lower, so the MI250 is much more efficient. It just depends on which thing you want to buy, which thing you want to optimize for. And to be sure, the A100 is a higher class of GPU. We're not, it's not flagship for flagship. It's not really exactly like for like. That's not the point of this video. The point of this video is just, is it viable? And how far has it come exactly in 8 months? Because we looked at things 8 months ago, but now we're looking at this in our Supermicro system, and things have come a long way in 8 months. So I've set this up as a like-for-like demonstration, and we're going to do it with Danny DeVito, of course. Danny DeVito explaining how his car ended up in the ditch while eating cereal. We'll run that on both systems roughly the same time. Now we can see back here at our terminal windows, I've got NVTop going, and I'm going to ramble a little bit. And our MI210 system is going to take about twice as much time. Remember, it's 2 instances doing 16 images each versus a single instance doing 32 images. The time will come down. It'll end up being about 1 minute and 20 seconds for the MI210 versus about 48 seconds for the A100, give or take. We need a longer runtime. It depends on the prompt and some other stuff. But we can see, we're using about 300 watts, 279, 280 watts, something like that. Over here for the H100, or the A100, I'm sorry, we're using 300 watts. Sometimes it'll go a little over 300 watts. The highest I've ever seen it was, I think, 340 watts, give or take. But mostly it's around 300 watts. It's pretty good. It's updating a second. We're not really using a lot of video memory or anything like that. This is NV top on this side. This is AMD GPU top on this side. We can see that our tools from the AMD GPU side of things are pretty mature. That gives us a lot of telemetry into what's going on inside the GPU. If you're a programmer, everything that you need to do any kind of troubleshooting or figuring things out or anything like that is already right here in whatever you need. And with the work complete, and I use the same seed and that sort of thing, you'll get the same result. You know, this AI stuff is not as random as it seems. It's actually quite deterministic, meaning you'll get roughly the same result. But if you dig into it and look at it, it's not quite exactly perfectly the same. The second image in our set is the easiest to begin to notice differences between the two systems. You take a closer look at the spoon and the buttons on the shirt. There are subtle buttons there. I don't know if the YouTube compression algorithm is going to destroy it, but there are black buttons on the shirt from AMD, and there's silver buttons from Nvidia. Now, it's like, what are the different? They should be exactly the same. There must be a bug, right? AMD's not ready for the prime time. No, actually, in fact, when you look at the specifications for GPUs, and it talks about floating point 64 performance, for example, it's like, you get so many trillion floating point operations per second with this GPU, unless you're doing AI top operations, and then it's insanely way faster. Well, the insanely way faster is that it's doing compression there that's kind of lossy. You know, your tensor cores are not working with a full floating point implementation, and most of the time it's fine. Like these images are substantially the same. AMD is not taking the same shortcuts with their implementation, at least not yet, or at least they haven't reached that level of optimization. Depending on how you want to spin that, you could say that NVIDIA's software solution is a lot more mature, and because of that, you get, radically better performance. But you could also say on the AMD side that what it's doing under the hood is more accurate, because AMD is not as sure of its solution yet, or its solution is not as tried and true as NVIDIA's solution, and so they're not willing to make those kinds of optimizations because it'll make future debugging a little more difficult. However you want to characterize it, however you want to spin it, under the hood, the math that's happening on the AMD side is more accurate. And so you get little subtle differences like that in the images as a result of that. The spoon looks more like a spoon. The buttons look more like buttons. Very, very subtle little details in these images. Same with this. We've got 4 buttons and maybe another one peeking out. And then on this side, we've lost a button, and they're not exactly in the same spot. There's other little subtle differences in every single one of these images. Again, subtle differences around the hand and some of the background stuff that's in the image. This image shows us some large differences. We ended up with a bowl of cereal, I guess, in this one, whereas there's a car and something else going on over here. I'm not really sure. The car in the background is also a little different. Again, little details in the headlights, little details with the car and the background and what's in the hand. Again, the buttons are a little different between the two systems. Not just that, but even the cloth texture of the shirt ends up being just a little different between the two systems. And it's a little more open, a little more buttoned down from Team Green. Interesting subtle differences as a result of just the loss of just a couple of the most insignificant bits you could ever think of. The angle of the spoon in this image and other little subtle details end up being just a little different between the two platforms. And this is not a negative. This is just a difference in how the accuracy is carried forward. And certainly the AMD dev teams are aware of this and they're working on this. And it's like, implement CUDA inaccuracy is probably a memo on somebody's desk, just so you don't have data scientists that are freaking out because there are subtle differences between this system and another system that they're using in order to do this. But the fact that AMD's performance is as good as it is without taking those kinds of shortcuts really should tell you what you're dealing with under the hood here in terms of hardware. The hardware is second to none. The hardware engineering is second to none. And we've seen that with the AMD data center event that just happened in San Francisco and what AMD is promising with the upcoming MI300. Well, it's actually an MI300A and a 300X, an APU and a GPU. But before we talk about that, we need to talk a little bit more about the performance side of that. The performance of Automatic 1111 shouldn't be something that you hinge, your thought process entirely on. It is the best, worst example of something for AMD. and even being the best, worst example, it's still pretty darn good. The fact that this is up and running on PyTorch with very, very small changes to Automatic 1111 in order to be able to produce basically an identical result really is truly breathtaking, especially considering where we were just a few months ago. If you look at the other benchmarks that are in the MLPerf benchmark suite, ResNet 5050, AMD was already basically there at parity. Remember their launch slide, delivering performance records in high-performance compute. Delivering performance records in high-performance compute, it was already outperforming an A100, the MI250, or the MXM version of the 250, basically. And AMD wasn't just making that up. That's just the raw math, the raw compute performance. For my own tests, running BERT, which is another one of the MLPerf benchmarks, running a single A100, so this is language manipulation basically, it's about 2100 examples per second between steps 100 and 200 on that single A100. For this dual MI210 system, I can achieve about 17 to 1800 examples per second between steps 100 and 200. That's like 85% the performance of the A100 in a similar-ish footprint. Again, viability and huge strides in software. I mean, that's multiple benchmarks in the MLPerf suite where AMD is within 15% of Nvidia. That's pretty darn good. Now, this really just shows that AMD's software ecosystem is finally becoming mature. I wouldn't expect these kinds of software gains for 300 series Instinct over the lifetime of the product. I take it more of a sign that AMD is leveraging what they're learning from their supercompute customers for their whole software stack. Everyone benefits, basically. In just February, there were headlines suggesting that we should worry about AMD and AI performance. Is it time for AMD to throw in the towel? And here we are in July, and the headlines are saying something completely different. Oh, we might have looked over AMD for AI and machine learning performance because the AI and machine learning companies are starting to use these libraries. I mean, look, the AI stuff is just math. There's hardware to do the math, and the hardware to do the math has already been here. It's been here the whole time. But the software path, at least for the non-PhDs working somewhere other than Oak Ridge, okay, maybe that part was lacking a little bit, but the hardware was here. But just like what Mosaic ML was saying, I'm seeing basically 75% of the performance of an A100, which gen on gen, the MI200 series and the A100 series, those are roughly the same generation. I mean, that's pretty good. Oh, and speaking of AMD hesitancy, there is also this recent event, kerfuffle news thing around George Hotz. He's a very famous software engineer, brilliant mind, and has been working in AI for almost 10 years. He founded a new company, AI, which is working on making AMD gaming GPUs work with AI because they're so cheap, and because AMD is already more open than anybody else, and because AMD's hardware performance is already there. They've already got the raw performance compute lead that they need. They just need the software to connect it up, and he wants to do that with AI. But Nvidia has done such a good job with their software and hardware ecosystem. His expectation was that the gaming and compute-focused products from every company are largely the same. And that's not really true with AMD. AMD has RDNA for gaming and CDNA for compute. And someday they might merge back together, but that day is not today. I mean, I've shown you the Instinct cards. This demo from today, that's CDNA, compute DNA. They're what's in the supercomputers. They're already viable for supercomputers. They're the building block for what AMD is doing. And they're more and more viable for more stuff with each passing day. And the context of this exchange with George Hotz and Lisa Su was that for what George sees as the future, he wants RDNA 3 to be where CDNA 2 is today in terms of the software stack. And yeah, that'll be good. Maybe those products will merge together in another generation or 2 or 3. that might be great. Meanwhile, a lot of people have remarked that it seems like Nvidia has forgotten gamers because they're able to sell their stuff somewhere else. But one thing I don't think Jensen realizes is that any success that Lisa Su and AMD have, it doesn't really take anything away from Nvidia. The aforementioned $40,000 H100 is not good for anybody. The future hasn't been written, but I think AMD is perhaps best positioned, more so probably than any other company, to incorporate and productize hardware and software breakthroughs, not just in AI, but anywhere. And the proof I have of that is in the upcoming MI300. It can be the fastest compute GPU the world has ever seen, maybe not. Or they can swap in some chiplets and have an enterprise-class APU, a single chip that has HBM2E, x86 cores, and GPU cores all in one package. I mean, AMD makes that look effortless. At Computex, Nvidia stole the show with Grace Hopper, a CPU and a GPU together. They're going to bring them together and it's going to be something amazing. Finally, CPUs and GPUs together, like nuts and gum. But AMD is over here, and they outed their MI300A and the MI300X. One is a pure GPU, as we've seen, and the other is mixed x86 and GPU chiplets with HBM2E on the same package. Isn't it obvious that that's the more advanced hardware? I mean, even with Intel, Ponte Vecchio is more advanced with its tiles and packaging and everything else. That's more advanced than what Nvidia is showing off. Am I the only one to notice that? I mean, yay, Nvidia has ARM. That's good. And that's going to help them with their product ecosystem. But the software is still closed. And how much of an advantage is closed software really today when you see all this momentum building behind literally anything but that? And just to give you another idea of how much the future hasn't been written yet, check out this submission from Neural Magic on ML Commons for that MLPerf benchmark. We've demonstrated some real serious gains in the component benchmarks that make up MLPerf for ROCm and AMD GPUs, but this is a result running purely on CPUs. This is CPU-based inferencing, meaning you take a neural net and you sparsify the matrix. That's their word. You really should check out Neural Magic. And it's possible to get GPU-like performance from multi-core CPUs for neural networks using this approach. This might be the future. Like I said, the future hasn't been written yet, but I also wouldn't bet against Lisa Su, because she's got all the stuff. Her CPU thing is more advanced, AMD's packaging thing is more advanced, and no matter what happens in the future, AMD is certainly going to be responsible for leveling the playing field by playing fair, no matter what actually comes about. That I can promise you. For AI and machine learning and even hybrid hardware approaches, AMD has been there, done that. They've got far better capitalization and far better recognition, and they're just killing it. Meanwhile, nobody even noticed that the Google's V5 tensor processing unit is MIA. And you really won't believe it's not CUDA, although it really did take them 264 iterations of ROCm to get there. So congratulations to the AMD team on launching ROCm 5.6, but don't let off the gas now. I'm Wendell, this is Level 1, I'm signing out, and you can find me in the Level 1 forums. If you got any experiments you want me to run, let me know, because this hardware is amazing. Thanks to Supermicro for letting me borrow this system. You should definitely check out our benchmarks and other coverage, and maybe pick one up for your lab, if no other reason, just to experiment, because oh boy, it's fast.